Okay guys, in this tutorial I'd like to talk about rendering paths. Now, some of you may remember some of these concepts that I'll be talking about, so I'll try to keep redundancy to a minimum, but this is meant to be a holistic explanation of all of these three approaches without a focus on any particular subject. Let's get started with the simplest but the most widely adopted lighting system called vertex lighting. Now, you can specify this individually, either in the camera here, and if you don't choose any of these options and just leave it as use player settings, it will just default to whatever you've specified in the player settings within your Unity file. And just go ahead and scroll down to the bottom until you see other settings. And in the rendering path now, I've got it set to forward. We wanted to set it back to vertex lighting, so I'm going to go ahead and select that and just click vertex lit. I don't need to click apply. And once we go to our light here and I try to choose shadows, either soft or hard, we're not going to see a result. If we hop back to the settings, switch this to forward rendering again, right away we see a shadow. Now say we wanted something a little bit more dramatic. I'm going to take out this directional light and I'm going to create a point light. And I'm going to give it just a little bit more intensity. Okay, now I want shadows for this point light too. Let's change the shadow type. Sure. Oh, no dice. Only directional lights can have shadows in forward rendering. And in fact, actually the limitations don't stop there. Forward rendering only allows shadows for one directional light. I'm going to go into the project settings, player, switch this to deferred lighting, and let's give it a little bit more dramatism so we can really see a shadow. Okay, well, there it is. Now, while point lights are actually the least expensive lights to render, point light shadows are the most expensive, lower than the GPU. But let's play around with them a little bit longer. I want to show you something else. I'm going to take off the shadows, and I'm going to switch this back to forward rendering. Oh, whoops. Project settings, player. Now if I were modeling a level, what I'm doing now would actually be terrible practice. I'm going to be using a lot of lights to light this one object. Typically you don't want to have more than one. But I want 4. This light here. I really want to make these visible, so just for the sake of being evident, I'm going to sacrifice aesthetic. Okay. And add one more. Now, when my hero is going to walk by, she is going to have a light attached to her. Now, obviously, I'm not going to script any of this, but I'm just going to duplicate one of these lights, and I'll move it off to the distance. And then I'm going to start moving this. Now as you can see, when I'm moving this, we see this sort of popping. Now I'm not sure if you can solve this popping thing, because it's not really a problem. In fact, it's more of a feature, and it's Unity trying to minimize the pixel shaders, and pixel shaders will give you things such as normals and shadows. Vertex lit lighting do not. If I want a smooth transition, no matter how bright any of these lights are, I've got several ways of solving them, but within forward rendering I have 2. I can go into the quality settings, Actually, I just got there accidentally a minute ago. And if I go into rendering, where it says pixel light count, I can set this to 5. I currently have 5 lights. If I'm planning having a total of 5 lights in my game, then all of the lights here will be pixel lit. We're getting a smooth transition. Now if I set this back to 4, the number of pixel lights that is, the second way I can get around the popping, or to have all of the lights be pixel lit, is to select each one of them, and there's going to be an option up here. It says render mode, auto important or not important. So we can read these as vertex lit, pixel lit, and this one will be determined at runtime depending on the brightness of nearby lights. Even though I've capped my pixel light count to 4, if I choose render mode to important on all of my lights, we will still get pixel lighting on all of them. Now, another gotcha that rendering paths have are their effects on particle systems. So I'm going to be creating something anything but complex, and just toggle a couple of settings in there. So game object create other particle system. And if you haven't done our course on the Shuriken particle system on Unity, you can definitely find out about all of these other settings up here and more. But in case you haven't, just dogmatically change a couple of these settings. What I want to do is I want to slow down the flow of these particles. So I'm going to give it a lifetime of 10 and the speed of 1, and that's it, actually. Now, the setting in which I'll be changing is something called a soft particle. Soft particles generally improve the look of a particle system, but one of their more dramatic effects is the interpenetrating geometry merging. So as we see these planes going in up here, these sprites, we see that they're going in, they're interpenetrating into this cube up here, into this crate, and overall it really loses the verisimilitude of any particle system you may have. Such as, for example, a flamethrower. You'll have a half a flame here and half a flame going into the other side. So deferred lighting renders everything per pixel and gives us an option to make this look a lot nicer. So to turn on this option, go to Edit, Project Settings, Quality, and click on Soft Particles. And this will only work in deferred lighting. So go into your player and choose deferred. Also, this will work, you won't see this in the editor. This can only be viewed in game review mode. Okay, this seems pretty good. Okay, and just click play. Okay, there's our particle system. And we see that when they're actually colliding with the cube up here, they're blending in, they're not popping out. Maybe you think that they're merging through. Up here they're popping out just because their lifetime ends. But when they're interpenetrating, you don't see half a sprite here and half a sprite there. I'm going to change this again just to, I guess just to prove it to you. Deferred lighting, I'm going to change this back to forward. And there they are, starting to clip. One more thing I'd like to point out before I wrap up is anti-aliasing. So if you remember back to our Photoshop example, I had two lines, one was smoothed out, and the other one you can clearly see the ladder, one pixel going into the other, and we saw a very crisp but very jagged diagonal line. So to resolve this, we need to enable anti-aliasing in the quality settings. Now, if I do enable it, in deferred rendering, we will still not see anti-aliasing. And this is an example, I just dropped out. This is an example of something being supported in both forward rendering and even vertex lighting that is not supported in deferred lighting. Now, there are actually ways around this, but through the default settings, anti-aliasing here, even if I do turn it on, this is just basically how smooth you will want it. We can go here in the medium. We will still not see any effect. Things are still just as jagged. So this is because we are in deferred lighting mode. So if we go to the player settings, now watch the lines here and turn on, for example, forward, right away we see things smoothed out. Vertex, of course, will change up our lighting, but anti-aliasing will still work. Last thing to keep in mind when choosing your rendering path is the platform for which you're going to be deploying on. For example, you want to reach a wide array of mobile devices, then Vertex Lit might be the way to go because a lot of the older iPhones will only support Vertex shaders. Most will support forward rendering, and actually the newest batch of mobile devices will actually even support deferred lighting, but that would be a relatively small market. Deferred lighting is also supported on most desktop PCs and modern consoles.